Now, how would I use this method to monitor the application I was talking about? So typically, I would place a monitor at the level of each of the entity, and I will connect them with a global supervisor. And we have taken a particular problem that consists in tracking an order of a client, Yahoo, in all these application. Now, how does the manager do this? Well, he needs to specify this kind of document, that is an active document, and this query is here. The active document typically has streams with information about the orders that have been detected at the particular entities, like the web stores, banks, the plants, etc. And the query here specifies that the order should come from a client Yahoo, and extracts two pieces of information. One is the identifier of the peer, and the other one is the identifier of the order. Out of these two pieces of information, it creates an alert that is sent to the web manager. Okay. Now, during our experimentation with the supply chain, we have realized that what we are actually trying to monitor was a notion that has been described in the literature and is known under the name of business artifact. This business artifact has been introduced by IBM in 2003 as a way of describing its business operations. So we have tried to adapt, actually to specify a model that takes into account our the particularities of our setting, and that answers to the needs of business artifacts. Now, while experimenting with the demonstration, we have seen that there is a need to have specific alerters, that we need to try to identify objects and to know potential trajectories these objects would follow. But what if we model such an application as a set of moving artifacts with some internal logic, and then the monitoring simply becomes some rules that are added to the logic. We have also seen that we need a powerful query language to exploit the results of the monitoring tasks that are the traces, and that needs to speak about the time, provenance, and relations between objects. We have looked in the literature mainly we have searched around papers on workflows. They are mainly operation-centric papers, but there are also some data-centric models that are described quite recently, so starting with 2003. And these models are mainly relational and non-distributed. They don't allow nesting, and they are used for verification. There has been work on workflows based on active documents, and what we actually want to do is to specify a powerful declarative framework for data-centric distributed applications. In our model, an artifact is an object with some identity, with some state that is an active XML document. It interacts as XML document through web services with the rest of the world. It is at the same time a server and a client, and as a server it has an interface. It is a nested model, so an artifact can have sub-artifacts. Then it evolves according to a logic that is carried with it at all time, and it possibly moves from one artifact to another. There is also a notion of workflow that specifies transitions between, let's say, macro states of such an artifact that are called here states. What is new with respect to ActiveXML? We have identifiers, we have a notion of workflow, we have interface, and we have a logic that instead of being at the level of the peer, as it used to be, now is at the level of the artifact and it follows it everywhere. Okay, if you go back to the monitoring problem, we model a distributed system as a set of moving artifacts and interacting artifacts. With respect to that, we have two types of systems. There are some legacy artifact-based systems that are not ActiveXML based. And for this, we still need to have alerters. We need to know where to place them, and there is incomplete information typically. But for the ActiveXML artifact-based system, monitoring service is simply a part of its logic. So it is a service to which one can subscribe directly. Now, as conclusions, we have developed two prototypes. One is Xlog as a maintenance module for ActiveXML. The other one is P2P monitor that uses Xlog. There are some interesting perspectives of such work. For instance, we can add aggregated aggregation queries. We can have more complex temporal aspects. For instance, one may want to know if a particular tuple becomes satisfied before another one. So if there is a possibility for such a thing. And there is many ongoing work around XML-based business artifacts. So in the end, here are some my publications. The second publication is actually in the series for PhD, so I haven't used the notions that were there in my presentation. I have participated to a research project that is called Dogflow, and I'm participating now to another one that starts. It is webinar. Thank you very much. I suppose that the jury has some questions.
Okay, so thank you very much, Logan, for your clear presentation. And as you said, it's now time for questions. As usual, we ask the referees to ask their questions first. And the first, which I mean, the man who came from the German part, is the first to ask questions, and shall ask to ask questions. So please, Hakus, to ask your questions. You have plenty of time to ask them